The next lesson we're going to be covering, 10.6, has to do with trigonometric ratios. What exactly is a trigonometric ratio? Well, we typically shorthand that to trig, or trigonometry. So a trig ratio, all it is the ratio of sides of a right triangle. So it's the ratio of side lengths of a right triangle. So let's say we have some right triangle here. And for trig ratios, we define this based off of a side or an angle. So let's look at these and let's look at how we would define these based off this angle. We would say this, well, that's always the hypotenuse. But what about this leg? We're going to call that the adjacent leg. And the leg that's further away, the leg that's opposite it, will be the opposite leg. So what ratios can we have for this triangle? Well, we could have three different ones. We could have the opposite to the hypotenuse, the length of the opposite over the hypotenuse. That's our first ratio, is going to be the opposite over the hypotenuse. And we call this one sine, and we define it based off that angle, so it's sine of A. We write that out as sine A or sin A. You might have seen the sin button and the cos and the tan button. This is what we're dealing with. Okay, what other ratios do we have? Well, we could have the adjacent over the hypotenuse. We call this one the cosine of A. This is the one that gets shortened to cos or cosine of A. And the last one we have is we could have some sort of ratio between these two. The way we write that is we do the opposite leg over the adjacent leg. And this is called the tangent of A, which is shortened to tan of A. Right. Now, this can be a lot to remember. So how do we remember it? Well, luckily we have a mnemonic device, an acronym for us. Acronym is SO, CA, TOA. How does this help us remember? Well, sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is your opposite over your adjacent. And all this lesson really comes down to is remembering these and using them in different ways. So let's run through a couple of examples. We're going to find the sine, the cosine, and the tangent of A. So if we have a triangle, remember these have to be right triangles. And let's say these distances are, this one's 17, this one's 15, and this is 8. Well then sine is so. So sine is opposite over the hypotenuse. Let's say A is this one. So sine of A will be the opposite leg, or 15, over the hypotenuse, 17. Cosine, ca, is adjacent over hypotenuse. So the adjacent is 8, hypotenuse is 17. This becomes 8 over 17. Tangent is toa. So tangent is opposite over adjacent. Opposite over adjacent means that this is 15 over 8. Let's do one more quickly here. Say you have another right triangle. Call this angle A. And this has sides 9, 12, and 15. So sine of A, the opposite over the adjacent, right? This, or opposite over hypotenuse. This is the adjacent, opposite hypotenuse. It's going to be 9 over 15, or we can divide both of those by 3, so this becomes 3 over 5. Cosine of A is going to be the adjacent, 12, over the hypotenuse, which we can reduce to be 4 over 5. And then tangent is going to be the opposite over the adjacent. So this is going to be 9 over 12, or we can reduce this to 3 over 4. So finding the sine, cosine, and tangent really is as simple as remembering so, ka, toa, and using those to find it. But this gets a little bit more complex because we can do other things with the trigonometric functions. The first thing we can do is we can find sides with this. Now this is where it's important that you have your calculators in degree mode instead of radian mode. So make sure that you actually go through and check that video I posted to switch it or find another video that puts your calculator into degree mode. Let's look at finding a side based off of an angle. So let's look for the value of x. We have some right triangle here. Oh, let's redraw that one a little bit more right. And let's say that you know that this angle is 48 degrees. We know the hypotenuse is 14, and we're looking for x. So we have some angle, and we're looking for x with the hypotenuse. X is which leg? It's the opposite leg. So we have opposite, and we have hypotenuse. Opposite and hypotenuse, let's see. So sine, opposite, hypotenuse. So we're looking at sine. We're going to say the sine of this angle, the sine of 48, is equal to your opposite leg, x, over your hypotenuse, 14. Now, we put this into our calculators. We figure out what sine of 48 is. We find that that's about 0.743. So this becomes 0.743. It's about x over 14. And how do we solve for x? Well, we just multiply by 4 to find that x is going to be roughly equal to 10.40. Let's have you rounding to the hundredths for every part of this. Okay. So we can find the side based off of whether we have an angle, right? We can find the angle based off of whether we have a side as well. This is going to use something we call inverse trig functions. So we can find the angles as well. What is the measure of angle, and this is a shorthand we use for angle, A? Let's say we have a triangle. We'll call this side A, this point B, and this point C. So angle A is the angle right next to that, and we'll call this side 12 and 24. So what do we have? We have the angle adjacent, and we have the side adjacent, and we have the hypotenuse. which trig function uses the adjacent and the hypotenuse? So opposite over hypotenuse, so not sine. Ka, adjacent over hypotenuse. So cosine is adjacent over hypotenuse. This means we're going to be using cosine. So what do we say? We say the cosine of that angle is equal to the adjacent over the hypotenuse. 12 over 24 is just the same thing as 1/2. So we know the cosine of A is equal to 1/2. And now here we can use something called an inverse trig function. You'll notice above the buttons on your calculator for each of these, you'll see something that says sine to the -1. That's the inverse. So what we're going to do is we can say the measure of A will be equal to the inverse cosine of whatever's on the other side. So if you're trying to find an angle, you're going to move the cosine or the trig function over to the other side as an inverse. The inverse allows us to find that angle by doing this. So put that into your calculators, figure out what that becomes. The inverse cosine of 1/2 is going to be 60. So angle A is equal to 60 degrees. That's how we find an angle. So this one right here is 60 degrees. So find the trig function that works, solve or simplify, and then take the inverse of whatever that function is to the opposite side. Now, where's this useful in real life? Well, trigonometric functions are actually how they determine the height of mountains. This was what they used for a long time before they had satellite imagery. And how does it work? Well, if you have somebody standing over here and you have some super tall thing like a mountain, we have a couple of different angles here. From this person to the tip of the mountain, there's an angle. That angle up we call the angle of elevation. And if there was a person standing here looking out, their eye line or their natural eye line would be horizontal like this. The angle down to where the other person is, that's something we call the angle of depression. So let's say you have somebody standing here and you know how far it is to the mountain. If you know how far it is and you know what the angle is, we can solve for how tall it is using one of our trig functions. Let's do that now. Let's say you standing, we'll say you are 400 feet away from a mountain. And the angle of elevation to that mountain is 40 degrees. How tall will the mountain be? Well, if we were to draw this out, we'd have 400 feet. We're looking for how tall this is. We'll call that y. And we know that this is 40 degrees. This is a right triangle. We have the two legs we're looking for. Which trigonometric function relates those two legs? Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. So tangent is what we're looking for. So we know that the tangent of 40 degrees will be equal to the opposite, y, over the adjacent, 400 feet. How do we solve for y? Multiply by 400. So this becomes 400 feet times tan of 40 degrees is equal to y. Now put that into your calculator. So again, you have to make sure you're in degree mode here. You'll find that the mountain is actually only 335 0.64 feet. Not really a mountain in this case, this is more of a hill that you're looking at. But that's how surveyors were able to determine the height of mountains before we had satellite geography. All right, that's all we have for the lesson. So we covered 3 different things you could do with trig functions. You could solve for them, you could figure out what sine of a value was. You could solve for a side, or you could figure out what the angle is. Let's have you do some practice with each of those now. Your first practice problem, let's give you this triangle. I want you to find the cosine of D and the tangent of E. We'll also give you one where you have to find the angle. You're given this is 14 and 8, and this is side A. What is the measurement of angle A? And finally, let's have you look at the length of a side. If we know that this is 10 and this is a 33-degree angle, what is the length of A? Right, so pause the video, do these problems, and we'll get started back when you guys are finished. Welcome back. Let's get to this. The cosine of D. Cosine. So, ca is adjacent over hypotenuse. So the cosine of D will be what's the adjacent leg? Is 12 over the hypotenuse. The hypotenuse will always stay the same. So this is 12 over 18, which we can divide those both by 6 to get this to 2/3. Tangent is TOA, so it's the opposite over the adjacent. This is angle E there. So tangent is going to be the opposite over the adjacent. What's the opposite? It's 12. The adjacent is 7. So this is 12 over 7. What's the measurement of angle A? So we have 2 sides here. These are the 2 legs. What relates the 2 legs? That's tangent. So we say the tangent of A is equal to the opposite, 14, over the adjacent, 8. These can both be divided by 2, so this becomes 7 over 4. Now how do we solve for A here? We take the inverse tangent. So we flip where the tangent is with that inverse, and we put that into our calculator. That tells us that A, the measure of angle A, is going to be approximately 60.26 degrees. If you're not getting this value, but you are getting this, it means your calculator's in the wrong mode. Make sure it's in degree mode. All right, and finally we have what is the length of A? What 2 sides are we looking at? We're looking at the adjacent and the hypotenuse. Adjacent and hypotenuse is cosine. So we have the cosine of 33 degrees is going to be equal to the adjacent over the hypotenuse. Get A by itself by multiplying by 10. And we get that A will be equal to 10 times cosine of 33 degrees. Put that into your calculator. You should get that that's equal to 8.38 or 8.39 will be your length. So we find that the length of that side is 8.39. Once again, if you did not get this answer, but you got to this step, it means your calculator's in the wrong mode. Make sure it's in degree mode. All right, that's the lesson, so go ahead and get started with the homework.